Also wanted to show you what I'm looking at for the drive system for the Elevons. Here's the one of the torque tubes I'm looking at for the Elevons, and at the end here you can see is a aluminum toothed gear. Here's another gear just like it. They come like this. They have a little hub on them, and I mounted one of these in a wood dowel stick and bonded the whole assembly into the tube, and then I ran pins through here, 16th inch diameter carbon fiber pultruded rods, and not through the aluminum part, through the sides, around the sides, and that will ensure that this does not twist out of the tube or pull out of the tube. I built this just for testing and playing around purposes. Here's a very short strip of the belt that goes with these. These gears and belt, timing belt, normally go in printers, usually 3D printers. This belt is urethane, and inside the belt is Kevlar. They are zero stretch. You couldn't stretch this if you tried, and they're extremely strong. So the torque tube for the Elevon will come out of the wing this way, and so that we get the phase correct. There'll be a 90-degree twist, and this will be attached to the joystick here, and that will then rotate the torque tube. There'll be a torque tube coming in from the right wing and the left wing, two of these guys, some bevel gears, and we'll do the mixing right there. This will be an extremely lightweight system, but also very, very strong. I think these will work out terrifically. I don't know if I'm going to use this diameter. Might use a larger diameter, more teeth, fewer teeth. There will have to be some covers here on a separate structure so that the belt can't back off of the teeth and keep it securely engaged. The belts are quite flexible. They could do more than a 90-degree twist and still operate, but they only have to go 90 degrees to get the Elevon control in phase with what the stick needs to do. So, very interesting solution. Not too heavy. The aluminum gears have a little bit of weight to them, but it's not too bad. A gear this size costs $6-7. The belt here, about the same price. They have longer belts, shorter belts. They have this as just straight material. You can cut the length and join up the ends and make any size that you want. So very handy. I took time in our little break there to prep both of the fittings that are going to go in the ends of the tube. I wanted to show you a little bit more about this belt drive gear. You'll see it has a little hub on it here. I drilled this out for a 1/4 inch bolt. They come 9mm nominally. So I set it up for a 1/4 inch bolt, and I've set up a wood plug here that's designed to accept that end of the gear fitting. I'm going to bond this in here and then run the bolt all the way through to hold it together. And the other thing I wanted to show you before we go back to just watching, I have cut, oh, there, we got some glue on it already. I have cut pieces of 1/16 inch unidirectional carbon fiber rod, and once these fittings are in place, I'm going to carefully drill through such as to miss the bolt. I'm going to run one this way and one this way. These will be shear pins that go all the way through the tubing and through this core and help prevent the core from twisting inside the tube when I do the torsional testing. So that'll be the final method of securing the plugs into the tube. The other end of the tube will be bonded into a large plywood plate. I'll get up here with a wrench and put a wrench on these babies, and there'll be a little collar around this to help steady it in place so that it doesn't go sideways, and we put a pure torque on it, and we'll find out where these tubes actually fail. For the one that I'm using the gear on, I'm going to use that for experimenting with the drive belts and connection up to the control stick for the pilot. So bear with me, and we'll get this all glued together, and you can watch. Here we go. Get that fitting bonded in here. Generous coating on the inside of the tube. And a nice coating on the plug itself. Torque fitting that we're going to use for the testing. Make sure everything's well bonded. Slip it in there, get down now flush and wipe off the excess. And set that aside. On to the next one. Remember, one of these tubes is going to be hollow. The other one's going to be filled with expanding urethane foam, two-part system. I'll have that in the next chunk of the video. You see that coming up. And we'll see the difference between the tube that has just a single wall and foam filled to find out the difference in strength between the two. It is my suspicion that the foam filling is going to be too heavy to be a viable solution, that adding the hoops of carbon fiber cloth at various stations along the tube will actually be the lighter weight solution. But the foam is quick and easy, and it's be an interesting experiment. In other words, you will have a foam core piece of tubing, very thin wall. Would be an alternate method that might use for tubing on the pilot's cage, or maybe we'll use it in tubing at the leading edge tube that goes inside the D tube, something like that, as a appropriate strength to weight ratio approach for that component, and reduce the amount of carbon fiber cloth being used and not build parts that are so over designed in one parameter just to get the other parameter that we're looking for, which happens often with composite materials. There, now we're all glued in. I'm going to go away and wipe off the excess epoxy, get it out of the gear. But there's the fitting on the end of the tube, and a belt will go over this and serve to drive the torque tube to drive the Elevons. And thanks for joining me.